Good morning to one and all present here. In this video lecture series, we are going to discuss about an additive manufacturing process chain. My name is Divya Kumar, Assistant Professor from Department of Mechanical Engineering, SNS College of Technology. In the last lecture series, we have discussed about challenges faced during the additive manufacturing process. Now we are going to discuss about the additive manufacturing process chain. What is an additive manufacturing process? The additive manufacturing process chain refers to the sequence of steps involved in converting a digital design into a finished physical part using layer by layer fabrication. Unlike conventional manufacturing process, AIM integrates design, simulation, fabrication and post processing into a continuous digital workflow. There are about different types of AM process chain or different steps involved in the process chain. Based upon the design thinking principles, we are going to discuss it one by one. First, we need to identify the key stakeholders and what are the common challenges and what are the essential needs for the particular type of additive manufacturing process. Next, we need to define the problem statements like how we are going to design it and how we are going to print it by layer and what are there are about different types of additive manufacturing process, what type of machine we are going to select it and what are all the different types of materials we are going to choose and made with the help of the AM process, and for what application we are going to define the particular type of machines. These are all some of the parameters or problem statements we need to define before we need to produce the particular type of the product. This slide is the step-by-step procedure which is used to follow during the additive manufacturing process. First one is the concept and product design. Product requirements are defined based upon the function, load and application. It can be designed using any one CAD software, and the design is optimized for additive manufacturing process, and also it includes lattice structures, weight detection and part consolidation, etc. The output can be in the form of an 3D CAD model. The second step is the design optimization, which can be produced with the help of any type of CAD model such as SolidEdge or SolidWorks or ProE, CATIA, etc. Third one is the file conversion. The CAD model is converted into an STL file format or AFM or 3MF format preparation. And also the model is approximately uses the triangular facets and errors such as gaps, overlaps or non-manifold edges are corrected. The major purpose is the machine readable geometry can be created with the help of the file conversion. Next one major step is behind it is process planning. That means selection of the AM process. As I had already told, there are about different types of additive manufacturing process such as fused deposition modeling, selective laser sintering, stereolithography apparatus, etc. We need to define any one particular machine based upon the application. And then we need to define the layer thickness, orientation of the parts, support structure, etc. Next one is the slicing and tooth path generation. The model is sliced into thin layers. The tooth paths can be generated for each layer, and the printing parameters such as speed, temperature, power can be defined. Next one is the machine setup and material loading for different types of AM manufacturing process. Next, layer by layer fabrication. Actual layer by layer fabrication takes place and material is deposited, cured or sintered in the controlled environment which is maintained for the preferred quality. Next one is the post processing operation. That means part removal and support removal. The printed part is removed from the build platform and the supports are removed manually or chemically, and the excess powder or resin is cleaned. It is mainly used to avoid the damage to the delicate features. Next step is the post processing operation such as heat treatment, surface finish, machining, infiltration or coating of the additive manufacturing parts. The eighth step is the inspection and quality control. Here the dimensional accuracy of the parts manufactured is checked and mechanical testing if required can be processed. We can either use the manual inspection or else different types of NDT, non-destructive testing. And then final application, there the part is assembled or directly used. Various types of applications, such as in aerospace, we can use it for aerospace applications or automotive applications, biomedical applications or tooling, etc. In summary, there are about majorly 10 steps behind the additive manufacturing process chain: concept and CAD modeling, design optimization, file conversion, slicing, toolpath, machine setup, inspection and testing, and then final applications and deployment. Thank you.